Hello. This is going to be the first of a series of videos that cover the first few sections of Chapter 1 that really just cover some preliminaries. This is not yet calculus. It's reviewing some of the most important things that we will need for calculus. But one thing I want to stress is really almost anything you have learned before in a math class could come up in doing a calculus problem. And it could come up unexpectedly. So it's not like, oh, for a month we're going to do calculus problems that involve trig and then we'll forget about it. And then we'll do calculus problems that involve exponentials and then we'll forget about it. It's just everything can come up all the time. So it's really important to stay sharp on some of these basic skills, and please ask when you don't understand something. It's actually very common that students understand the calculus part of a calculus problem pretty well, but they can't get to the correct answer because of algebra errors or trig errors or arithmetic errors or not understanding how to graph something, right? Usually it's those pre-calc things that show up. So as they show up as you do practice problems, study, think about it, ask questions, etc. Okay, so a few things that I'm not even going to talk about now, but you absolutely need to know is, how does a coordinate system work? What do we mean by the x-axis and the y-axis? What do we mean by the origin? How do we number the quadrants? What do we mean when we say something like an x-intercept or a y-intercept? Linear equations just mean an equation where we're not doing anything more complicated than just multiplying the variable by a number. Right? So no trig, no exponents, no squaring. Slope, you should certainly understand how to calculate. We'll talk a little more about its meaning later on in this section. And then you should know what domain and range are. Right? I will just here mention domain is the set of all input values. Often these are labeled as x, but regardless of what it's called, we're thinking of what are all the input values. And range would be what are all the output values. And sort of built into this is you need to be comfortable with the idea of a function and its notation. So we're going to get into details about a few more things. All right, first thing, and this maybe you haven't seen, but it's worth knowing, it comes up in certain problems, is the distance formula. So the idea is, if we have 2 points in the plane, let's suppose I have a point here at 7, 1, and I have a point here at 2, 5. And I want to know how far apart are they, right? What is this distance? So, think about how could you do this? One approach, and this is the more deliberate approach, is we could draw a right triangle. I'll draw it like so, although I could have drawn one with the corner up in the upper right like this. But I draw a right triangle where one side is perfectly horizontal and the other side is perfectly vertical. That would mean that this point here has an x-coordinate of 2 and a y-coordinate of 1. What's really nice is when things are horizontal or vertical, it's very easy to compute how far apart they are. Here I'm traveling perfectly horizontally. Here I'm at x equals 2, here I'm at x equals 7, so those are 5 units apart. Here I'm traveling perfectly vertically, those are 4 units apart. And now we can do the Pythagorean theorem. So 4 squared plus 5 squared equals d squared. 16 plus 25 equals d squared. And d would be the square root of 41, which doesn't simplify, but it's around 6.5. It's faster if you just know a formula for this, rather than having to draw the picture every time. So let's think about this. Where did that 5 come from? That 5 came from subtracting our 2x coordinates. 2 minus 7, 7 minus 2, it really doesn't matter the order. But we subtracted those and we got 5. Where did this 4 come from? That came from subtracting the y coordinates. And then we did the Pythagorean theorem. right? So the distance here was the square root of 4 squared. Sorry, I'll say 5 squared plus 4 squared. And that's what this is doing, right? We have one big square root, and here we are subtracting our 2x coordinates and then squaring it because of the Pythagorean theorem. Here we are subtracting 2y coordinates and squaring it because of the Pythagorean theorem. In theory, you can always draw a triangle if you need to do this. There will be examples where that is going to be extremely complicated because maybe we're using variables instead of numbers. I strongly recommend that you learn this if you don't already know it. And you'll do some practice for homework. Also, if we have 2 points, we might want to know where is the midpoint between them. So let's suppose here I have a point at, say, -1, 4, and here I have a point at 7, 2, and I'm imagining if I travel straight between them, where is the point that's exactly halfway? And I'm going to ask a related question. So here's a question. You don't necessarily have to write this down, but I want you to think about this. How do we find the midpoint? I'll put that in quotes because it's not a geometric midpoint between two numbers. So for example, if I had the number 10 and I had the number 32, and I asked you what comes in the middle between those two numbers, right? Pause and think about what number do you think is between them and how did you get that? There are a couple ways to do this. You could say, well, these numbers are 22 apart, so halfway would be 11. And if I count forward 11 from 10 or backwards 11 from 32, either way I get 21. A faster way to think about this is we actually just did the average. 10 plus 32 over 2. When I average those numbers, I get 21. So here's the good news. If we want to find the midpoint between 2 points, the point that's halfway between, all we have to do is average twice. The x coordinate of that point will be halfway between the two x coordinates, so we average them. And the y coordinate of that point will be halfway between those two y coordinates, so we average them. So take a moment and apply this formula, see what you get, and then check that it seems plausible from my picture. I drew the picture by hand, it's not going to be perfect, but see if you get an answer that makes sense. All right, so let's just check this. This x coordinate would be -1 plus 7 over 2. This y coordinate would be 4 plus 2 over 2. This first one simplifies to 6 over 2, which is 3. The other one is also 6 over 2, which is 3. And that seems very believable to me. If I add my tick marks after the fact, which maybe you'd think of as cheating, right, that looks about right. Okay, I'm going to pause the video just so each individual video isn't too long.